Today we're going to be talking about properties of logarithms. This is section 8.4 in the Algebra 2 book. There are three properties of logarithms that will be helpful to you when you're trying to solve equations in the next lesson. The first property is called the product property of logs. I don't really care if you know any of the names specifically. It's more importantly that you know what the property is and how to use it to your advantage. The product property says that when you have addition between two logs, then you can squish those together as one log by multiplying the things together. Addition between logs means you're multiplying the stuff. Here's our example. Log base 2 of 3 is being added to log base 2 of x. See how there's a plus sign between our two logs? That means I can squish the 3 and the x together by multiplying them to make 3x. So my final answer would be log base 2 of 3x. Okay, you try this one. Log base 3 of 6 added to log base 3 of 5. We're going to squish those together, and what would it make when we squish them together? Log base 3 of 30. 6 times 5 is 30, so log base 3 of 30. Okay, the second property is called the quotient property of logs. Again, I don't really care if you know that name. I just care if you know how to use the property and what it does. This means that when you have a minus sign between two logs, you're really dividing them together, so you can squish them together as one log using division. Subtraction between logs means that you're dividing. The first number is the numerator, the second number is the divisor. Okay, here's our example. Log base 2 of x minus log base 2 of 4. I can squish these together as one logarithm, and I'm going to be dividing because of that subtraction sign. So log base 2 of x divided by 4. You try this example. You have log base 5 of 18. You're subtracting log base 5 of 3. So if you squish those together, what would it look like? Log base 5 of 6. 18 divided by 3 is 6. So log base 5 of 6. The third property is called the power property of logs. This property is probably the most difficult of the three for you guys to remember, and it means that when you have a number in front of a log, it moves up to the exponent for what you're taking the log of. N is the exponent for m. Here's our example. 2 is in front of the log base 3 of 3x. So that 2 is going to move up to the power of the 3x. The 2 in front moves up to the power of the 3x. 3 squared is 9, x squared is x squared, so this is log base 3 of 9x squared. Okay? You try this one. You have 1/3 in front of the log base 727. Where does that 1/3 move, and what does it give us for an answer? Well, the 1/3 is going to move up to the power of the 27. 27 to the power of 1/3. Make sure you put that in parentheses when you type it in your calculator. 27 power parentheses 1/3 close parentheses. That's 3 for an answer. So log base 7 3 is our final answer. Okay, we're going to do a little bit of practice. Here's the first one. Now we have two properties being used here. The third property we learned, the power property we have here, and we have the rule about the subtraction. That's the quotient property. So what we're going to do to start with is we're going to take that 3 in front and we're going to move it up to the power of the x. So it's going to become log of x cubed minus log of 4. Now the subtraction sign means that we can divide, so we're going to give a final answer of log of x to the third being divided by 4. Okay, on number 2, the plus sign means that we can multiply. So we'll have log base 2 of 5 multiplied with x minus 6. Now you can distribute that 5 if you want to and say 5x minus 30, but 5 times x minus 6 is completely correct and fine. On the third one, we have a 2 in front of the first log. That's going to move up to the power of 5. And we have a 3 in front of the second log. That's going to move up to the power of 2. 5 squared is 25. 2 to the third is 8. So we have log base 6 of 25 plus log base 6 of 8. Now the plus sign between the logs means that you are really multiplying. So 25 multiplied by 8 is 200, and we have a final answer of log base 6 of 200. Alright, now we're going to be expanding. This is starting with it all squished together, and then we're going to expand it back out into separate logs. So on the first one, we have division, which means we're going to separate these back out with a subtraction sign. So the first thing we're going to do is separate them out by saying log of x to the third minus log of x squared. Now the 3 in front of the first log, or on the power, is going to move out in front of the first log, and the 2 as the power is going to move out in front of the second log. So our final answer would be 3 log x minus 2 log y. Okay, on number 2, we have multiplication going on. We have 5 being multiplied by x to the 4th. So the first thing you want to see is how to separate the two logs that are being multiplied. You're going to separate them out by an addition sign. So you have log base 3 of 5 added to the log base 3 of x to the 4th. And now the power on the second log is going to move out in front of that second log. So our final answer would be log base 3 of 5 plus 4 log base 3 of x. Alright, for the last one, we have multiplication going on between the x and the y, and then we have division going on with the z. So we're going to separate 3 different parts, an x part, a y part, and a z part. Okay? With x and y, they're going to be separated by a plus sign because that's multiplication, and then z is going to be separated by a subtraction sign because it's division. So our beginning part is log of x, and then plus log y squared, and then minus log z to the 4th. Now you have an exponent on the second log, and you have an exponent on the third log, and they're going to move out in front. So our final answer would be log of x plus 2 log of y, and then minus 4 log of z. Okay, that's how you expand back into separate logarithms. Other properties that are important to know, but are not really things that have special names. It's important to know, number 1, that a log that doesn't have a base written has a base of 10. If it just says log of 30, log of 50, log of 82, it means your base is 10. Anytime the log does not have a base written, it's a base of 10. The log of 0 is no solution, you can't do it. If you don't believe me, type it in your calculator. Log of 0, it'll tell you error, you can't do it. Also, you can't take the log of a negative number, that's also no solution. You can only take logs of positive numbers. Okay?